Welcome to the Ecotechie. In today's video, we are going to further our discussion of decision tree. We are going to learn the tree complexity in decision tree. In the previous video, I gave a brief introduction of different types of node, the root node, the internal node, and at last the leaf node. Here we are looking at the tree complexity. Why are we looking at tree complexity? Because if we do not look at the tree complexity, it may become computationally very heavy. And when things are computationally very heavy, it will entail a lot of time. And when time is equal to money, it will entail a lot of cost to the company. Hence, it is important to understand the tree complexity. Now, the tree complexity is measured by the following. The first one is the total number of nodes, that is the root node, the leaf node and the internal node. We are going to add up everything and see how many nodes are there. The next one is the depth of the tree. We want to see whether our tree is deep or whether it is shallow. Then we have to look at the number of leaves, that is the final nodes. And finally, we have to look at the attributes. So all these contribute to the tree complexity. Now we know that there is tree complexity. Now there should be a solution also to this tree complexity. So there are two ways to handle tree complexity. So the first one is stopping criteria. Now how does this stopping criteria work? Now I am building my tree and at a certain point I decide enough. I don't want any more tree complexity. I'm stopping the tree over there. The next one is pruning. So in pruning, I will build the entire tree and at the end, whatever I do not want or which is increasing my time complexity and tree complexity, I will chop them off. So it is always preferred to use pruning because you have seen the growth of your tree and then you are deciding where to cut it off. So I hope stopping criteria and pruning criteria is clear for all. So in stopping, you are just abruptly stopping in the middle without even thinking whether the complexity would increase or reduce when you increase the number of nodes. And in pruning, you are first making the full grown tree and then chopping it off where your complexity is increasing. Now, there are several types of decision tree. There are top-down approach and then there is bottom-up approach. I'm just going to talk a few lines about top-down approach. Now, there is something known as iterative dichotomizer 3. So what does it do? It repeatedly divides the features into two or more subgroups at each step. So you have your internal node. That internal node is broken down into two or more subgroups. Then you have your C4.5. It is nothing but an extension of your ID3. So basically, someone just tried to improvise ID3 and they came up with C4.5. And remember, these two are related to classification. C4.5 is also called as statistical classifier. And then you have CART. And as I had said earlier, decision tree is used for both solving regression problem and classification problem. So CART stands for classification and regression trees. I will go into deep in my future videos, but for a preliminary understanding, we just have to understand that these are the different types of decision tree. Now you have to split the tree. Now you have to, it's like you are deciding whether a person has corona or not depending on whether he has cough or not. This splitting is happening. So such kind of splitting is called univariate splitting. An internal node is split according to the value of just one attribute. So basically, I am saying that if this person has cough, then he has corona. That is just a single attribute which you are using to split and come up with a result. Now, there are several univariate splitting criteria. There is something known as impurity-based criteria. There are distance-based criteria. Now, let us look at the impurity-based criteria in detail. So first you have your information gain. Information gain is an impurity based criterion that uses entropy. Entropy we have studied, it is nothing but the amount of randomness in your data. So in this information gain, it is using the amount of randomness in your data to make the splits. The next one is Gini index. It's an impurity-based criterion that measures the divergence of the probability distributions of target attribute values. Next, you have your likelihood ratio chi-square distribution. If you want to study deep, you can go and study in deep, but over here I'm just giving you it in one line so that you understand what exactly these criterions are doing. So this ratio is useful for measuring the statistical significance of information gain criterion. DKM criterion. The DKM criterion is an impurity-based splitting criterion designed for binary class attributes and normalized impurity based criterion. So all the previous criterions that you saw, these were not normalized. And we know that if it is not normalized, if one value is very large, it will change the entire criterion in its favor, which is not a situation we would like to encounter. So it is recommended that you normalize all the previous criterions that we looked at. Next is your gain ratio. The gain ratio is nothing but the normalized version of your information gain. Another one is binary criteria. It helps to create binary decision trees. The next one is the Kolmogorov-Smirnov criterion. It is a distance criterion, and then you have AUC splitting criteria and orthogonal criterion. In the future videos, I will be talking in detail about all these criterion. This is not the end of all the criterion. There are few more. You can learn more about it in my future videos. I hope tree complexity, the various measures of tree complexity and the different univariate criterion for splitting is clear for one and all. Thank you. Do like, share and subscribe to the Ecotechie. If you have any queries, please feel free to post it in the comment section below. Thanks for watching.